Welcome to this new activity, which is about finding the absolute maximum and absolute minimum of functions at the given intervals. So I will show you a method which works on closed intervals AB, okay? So the first step is to find the critical points. So let's apply it to the first example. So the first step, find the critical points. And you know that critical points are points in the domain of the function where f prime of x equals 0 or f prime of x is not defined. So critical points here. First step is to find f prime of x. The function is 9 minus x squared. Its derivative is negative 2x. Okay? Let's set it to 0 equals 0, which means x equals 0. So this is a first critical point, since it belongs to the interval negative 4, 4, so it's in the domain of the function. Now, is there a point where f is defined and f prime is not defined? No, because the negative 2x is defined everywhere, so there is no points where f prime is not defined. Let's move to the second step. The second step says evaluate f at the critical points and the endpoints. Which means that we're going to compute f of x for the critical points and the endpoints, which are negative 4 and 4 here. Therefore, we're going to draw a table, okay? We'll put x and f of x in this table. So we have x, f of x, which is 9 minus x squared. The first point is the critical point 0. The endpoints are negative 4 and 4. For x equals 0, f of x will be equal to 9. For x equals negative 4, f of x will be equal to negative 7. And for x equals 4, it's also negative 7. Here, you identify the highest value. It's going to be your absolute maximum, and the lowest value will correspond to the absolute minimum. Therefore, we can conclude here that we have an absolute or global maximum. So our absolute maximum is at x equals 0, since the 9 here is the highest value, and the lowest value, of course, is negative 7. So we have an absolute or global minimum, at which point we have 2 points here. So we're going to say at x equals negative 4 and x equals 4. You may have the same absolute minimum at different points, okay? Now, let's move to the second function. Going to do the same procedure on this function to find the absolute maximum and the absolute minimum. So first of all, we check that ln of x is defined on 1, 2, okay? Now we compute f prime of x, which is equal to 1 over x, okay? We set this function equal to 0, and we see that there is no solution here. It can't be equal to 0, so there is no point where f prime of x equals 0. Now, is there a point where f is defined? It means on 1, 2, and f prime is not defined. No, the function 1 over x is defined on the interval 1, 2. So the conclusion is that there is no critical point for this function. There is no critical points, okay? Because we didn't find any point where f prime of x equals 0 or f of x is defined and f prime of x is not defined. Therefore, there is no critical points. Now, we're going to just draw our table, put the x and the f of x, and compute, okay? So, x, f of x, since we don't have critical points, we will just put the endpoints, which are 1 and 2. Compute f of x, ln of 1 is 0, ln of 2 here is approximately equal to 0.69. Just to compare the two values, we need an approximation of ln of 2. Now, what is the lowest value? The lowest value is at x equals 1, and the highest value is at x equals 2. So we have our absolute maximum at x equals 2 and our absolute minimum at x equals 1. Okay? We are done with this activity. See you in the next videos.